Dr. Gigi Kriba, Assistant Professor, EEE Department at Vailtech Multitech, Dr. Rangarajan, Dr. Sahundala Engineering College. Hello students, today we are going to study Unit 5, Power Conditioners and UPS. In this video, we will first understand power line disturbance, then we will see UPS system and filters. Power line disturbance. Power line disturbance are unwanted changes in voltage, current or frequency. In an ideal system, voltage should be constant, but in real system, it keeps changing. These changes can damage equipments and reduce efficiency. For example, what we say is sometimes your fan speed changes or a light flicker. This is happened due to power line disturbance. Then classification of power line disturbance. Voltage disturbance. The voltage disturbance happens due to voltage sag, voltage swell, over voltage and under voltage. Voltage sag means when you switch on an air conditioner or motor, you may notice light becoming dim. This is called as the voltage sag. Voltage swell means when a heavy load is suddenly switched off, voltage may increase for a short time. This is called as the voltage swell. Then over voltage and under voltage means if voltage remains high for a long time, it is called over voltage. If voltage remains low for a long time, it is called as the under voltage. Both conditions can damage electrical equipments. Then interruptions. Interruptions consist of short interruption and long interruptions. Interruptions means complete loss of power supply. Short interruption is like a quick power blink. Long interruption is a power cut. Then transitions. Transition consists of impulsive transition and oscillatory transition. Impulsive transition, a good example is lightning. You may notice that when lightning strikes, it creates a sudden high voltage spike. Oscillatory transition means when power is switched on, sometimes voltage oscillates before becoming stable. That is called as the oscillatory transition. Then waveform distortion. This waveform distortion happens due to harmonics, notching and noise. Harmonics means device like mobile charger, computers and LED light create harmonics which distort the waveform. Noise means noise can come from nearby electrical equipments like motor or radio signal affecting the power line. Notching means notching occurs in power electronics devices like converter where a small cut appears in the waveform. That is called as the notching. Then voltage fluctuation. Voltage fluctuations are small repeated changes in voltage. This can cause light flickering, especially near welding machine. Then frequency variation. Frequency variation occurs when there is an imbalance between power generation and load. This can affect sensitive equipment. Then causes of power line disturbance. The main cause of power disturbance are fault, switching operations, lightning, non-linear loads, poor wiring and overloading. These are all the causes of power line disturbance. Then effects of power line disturbance. This disturbance can cause equipment failure, overheating, data loss and reduce efficiency. Then mitigation techniques. To reduce this problem, we use different devices. Surge protectors will protect against spikes. UPS provides backup during power failure. Filter will reduce harmonics. Proper grounding improves safety. Then we are going to see about offline UPS. In offline UPS, during normal condition, load get power directly from mains. When power fails, it switches to battery and inverter. There is a small delay in switching. For example, what we say is in home, when power fails happen, inverter turns on after a small delay. That is called as the offline UPS. The working is during normal condition, the load get power from mains. When power failure happens, switch changes to battery backup. The switching takes a small time delay, that is a few milliseconds. The main components in offline UPS are battery, inverter, charger, switch and relay. The advantages of offline UPS are simple design, it is low cost and small size, it is good for home and small office use. The disadvantages are small switching delay, less protection compared to online UPS, not suitable for very sensitive equipment. Then online UPS. In online UPS, power always goes through inverter, so even if main fails, there is no delay. This provides better protection. For example, what we say is in hospitals or data center, power should never stop. So online UPS is used which has no delay. Working, AC mains is converted into DC by using rectifier. Then DC charges the battery. DC is converted back to AC by using inverter. Load always receives power from inverter. Here if main fails, battery continues to supply power intensely. The main parts in online UPS are rectifier, battery, inverter, charger and filter. Then applications are server, data centers, hospital, it is used in communication system and laboratory equipment. Then advantages are it has no transfer time, it provides better regulations, best protection for sensitive equipments, it is suitable for critical loads. Disadvantages are it is more expensive and more complex design, it generates more heat, lower efficiency than offline UPS. Then we are going to see about the need for filters and filters for pulse width modulation, voltage source inverter. Pulse width modulation voltage source inverter. It converts DC into AC using pulse width modulation switching. Here the output of pulse width modulation voltage source inverter is not a pure sine waveform. It contains some fundamental AC components and high frequency harmonics and switching ripples. So a filter is needed. Need for filter in pulse width modulation voltage source inverter. Why filter is required means because the output contains some harmonics. We use filter to smooth the waveform and improve the power quality. The main need of filters are to remove high frequency harmonics. It is used to reduce the switching ripple and to make output waveform smooth and nearly sinusoidal. It is used to improve power quality and it is used to reduce total harmonic distortion and to protect the load and motor and equipment to reduce electromagnetic interference. Without filter, what happens means output is a pulsating pulse width modulation waveform. It contains many high frequency components. By using a filter, high frequency components are removed. Output becomes almost sinusoidal AC. Then types of filters used for pulse width modulation voltage source inverter. The main commonly used filters are LC filter, L filter and LCL filter. LC filter. LC filter uses inductor and capacitor. It gives good smoothing and it is commonly used. It consists of inductor in series and capacitor across the load. Working is inductor oppose sudden current changes, capacitor smooth voltage ripple. Both inductor and capacitors work together to reduce the harmonics. Advantages are better smoothing, good harmonic reduction. These LC filters are commonly used filter. Then L filter. L filter uses only inductor. It is simple but less effective. It consists of only series inductor. Working is to reduce current ripple. Advantages is simple and low cost. Limitation is less effective than LC filter. Then LCL filter. LCL filter gives better harmonic reduction and it is used in grid connector system. It consists of inverter side inductor, capacitor in middle, grid load side inductor. Mostly used in grid connecting inverter. Advantages is it is very good harmonic attenuation. Then the simple block representation of pulse width modulation voltage source inverter. First PWMVSI, that is the pulse width modulation voltage source inverter, convert DC power into AC power. However, the output of the inverter is not a pure sine waveform. It contains some harmonics and switching noise. So we use a filter after the inverter. The advantages of using filters are output becomes near sinusoidal. It reduces harmonics and reduce noise. It is used to improve the efficiency of load, better performance of motor grid system, lower heating in equipments. So finally we say that power line disturbance affect the power quality, and devices like UPS and filters help maintain a stable and reliable power supply. Thank you.